So what's happening here? What kind of degree, odd or even on the left? Even, why? They're going the same direction, right, Baluch?
Yes, same direction.
Okay, same direction, so the degree is even, okay? And leading coefficient, is it positive or negative? Positive, because the far right's going which way? Up. Degree, even or odd? Odd, because they're going opposite directions, right? And leading coefficient, positive or negative? Negative. The far right's going down. Okay? You got that, Colin? You learn all that right now? Just boom. All right. You know what the leading coefficient and the degree is yet? Kinda, maybe, sorta. Good. All right. Why is that not working? Have to redo it. I guess we'll just go without. You guys will just turn your necks, turn your heads. All right. Homework. Any questions on? Let's just do 246 right now. What are we looking at? Right and stand. Oh, I didn't give you an answer thing to look at. So I guess I'll just have to give you the answers. All right. So this was page 158, right? Number 2. It is a polynomial. It should be 6x to the fourth minus 4x cubed plus 1/2 x squared plus 3x minus 1. So the degree is 4, which is a quartic. The leading coefficient is 6. All right, we good on that? Number 4, it is a polynomial function. It should be written in this order: 13x squared minus 12x plus the square root of 3. That means the degree is 2, which is a quadratic. Leading coefficient is 13. Number 6 is not a polynomial because of this x in the denominator. Okay? You got an x in the denominator or in an exponent, it's not a polynomial. All right? Number 8. It's not a polynomial function. Why? The square root of x. You can have the square root of a number, but not the square root of an x. Because that means the exponent for x is 1/2. And the exponents for polynomials are supposed to be whole numbers, right? Evaluate. All right, so that's putting 3 in for x, -7, -12, and -1/3. So what number did we start there? 10 is 61. 12 is 16,193. 14 is 2,101. 16 is 76/27. 76 over 27. All right.
Good morning.
When you put
At this time, we need all cheerleaders participating in the rally.
You got to put it in like that.
Jim,
When you put it in your calculator.
now. All students
Right, just put
football
-1
players
divided by
start
3.
the rally.
And you put it in.
Go to the rally now.
All right. 16 was where we stopped there, right? Was that right? And then where did we jump to? 19? Bars? Bars. What's next after 16? Did we have to do 18? We did?
Yeah.
Okay. The weight of an ideal round cut diamond can be modeled by that function where W is the weight of the diamond in carats, and D is the diameter in millimeters. According to the model, what is the weight of the diamond with a diameter of 12 millimeters? So all we're doing is plugging 12 in, right? So 8.53 would be the answer when you plug 12 in. All right. Then what?
19, 20, 21, 22.
Okay. 19. As they have it, this is how I just told you to do arrows, right? So let's just redo arrows because. All right, so it's in the right order. So it's a negative leading coefficient, which means the far right's going down. And it's an even degree of 4, so that means the far left's doing the same thing. Okay? 20, positive leading coefficient, so the far right's going up. Odd degree, so far left's going down, opposite direction. Negative leading coefficient, so the far right's going down. Even degree, so same direction, far left's going down. This one's not in the right order. What should be first? The negative 5x to the 5th, right? That should be first. So negative leading coefficient, far right going down. Odd degree, so far left, opposite direction, going up. Yes?
I don't think it matters, but 21 isn't that out of order too.
Oh, it does. It does matter. Yeah, I didn't check. I didn't even look there. You're right. Sorry. Thanks. Right. So this is going to change. All right. So positive leading coefficient, far right's up, and even degree, same direction. So far left is up. I didn't even catch that. Going too fast. Questions on those? Okay. Then where do we jump? Was that it?
26, 28.
26 to 30.
Oh, that's right. Those were the graphs, right? All right. So those you just put in your calculator, right? Do we have any problems with our calculator? All right. So far, so good. Is that any questions? It's Elena. Does that help? Okay. We're good? And no other questions on the homework? Okay. So let's do a few things today. I'm not giving you any homework, okay? We'll just start talking about this. We'll finish talking about it Monday, okay? But some other characteristics of functions. Okay, we talked about end behavior already. Now the book wants us to show, show it like this. I just use the arrows, okay? But what this is saying, as x approaches negative infinity, y approaches negative infinity, meaning it's going down on the left. Negative infinity is the left for both. That means it's going down, all right? As x approaches positive infinity, as we go this way, y also approaches positive infinity, okay? That's how we're supposed to write it, but I just let you do the arrows, okay? We're not going to get real technical on that. Now, talking about when a function's positive and negative, this left third of this slide here. A function is positive when its graph lies above the x-axis. So the blue part is above the x-axis. Those two parts, two blue sections, okay? The function's positive, all right? When the function's negative, that means when the function is below the x-axis. So the red parts are below the x-axis, so that's when the function's negative, okay? Now, talking increasing and decreasing, all right? Looking at it left to right, it's going up until I get to whatever x value that is. Let's say it's a -2 there for x. So it's increasing from negative infinity to 2. Then it's decreasing, let's just say it's from 2 to 2. That spot there's an x value of 2, and that spot there, negative 2 and a positive. So it's decreasing, going down left to right, from an x value of negative 2 to positive 2, let's say. And then it starts going up again from positive 2 to positive infinity. All right, so understand what it means by increasing and decreasing. Left to right, as it's going up, it's increasing. Left to right, as it's going down, it's decreasing. Positive and negative is different. What part's above the x-axis is positive, and the parts below the x-axis is the negative. Okay? So understand the difference. So it could be increasing, but be negative, right? You see that? It's increasing right there, but it's also negative until it gets past the x-axis and it's increasing and positive. Okay? So you got to think a little bit. Questions on that? So above the x-axis, our function's positive. Below the x-axis, our function's negative. Looking at it left to right, increasing, decreasing, okay? All right, so approximate when the function is positive, negative, increasing, or decreasing. And then describe the end behavior. We know it's going up on the left, far left, and going down on the far right, right? So when we say approximate, we're just going to use inequalities, okay? So the function, they used y, but the function, we could say f of x, is greater than 0. Function is less than 0. Greater than 0 means it's positive, right? Less than 0 means it's negative, right? So let's look at that. What inequality is the function above the x-axis? What point is that? What number for x is that? 3, right? So from 3 this way, so what's this way on the x? What's way down there? Negative what? Infinity, right? Negative infinity is way down there. This graph, according to this picture, is positive, right? It's all that is above the x-axis, right? So from negative infinity, I guess we could say to 3. That would be our inequality. It's above the x-axis. From 3 this way, where's the graph? Below. So from 3 to infinity, it's below the x-axis. Okay? We're just looking at the x values. All right? Now, where's it? So that's positive. Remember, here was the positive, here's the negative, okay? Increasing. All right, so left to right, it's increasing. So from what point's that? What x value is that? Sorry. 0 to what x value is there? 2. All right, so it's increasing from 0 to 2. See that? That's the only spot, right? It's decreasing from negative infinity to 0. And from 2 to infinity. Okay, so we just write inequalities for those sections where it's positive, negative, increasing, and decreasing. Remember, we're looking at the x values. We're not looking at the y values. Look at domain. Remember, domain is the x value. What do we call the y values? The range, right? Okay. So what happens sometimes is kids will start putting y values in, okay? We're talking about the x values, when it's decreasing, increasing, positive, and negative. Okay? Does that make sense? All right, you guys try this one. Remember, when's it positive? Meaning greater than 0. Negative, meaning less than 0. Increasing and decreasing. Go ahead. Then we'll go over here in a minute. Then that'll probably be all we can get done today. I'll give you 2 minutes. Shouldn't be too bad because this is just a regular polynomial that's going down. Just got in your head, huh? No, that's not how I want to do it. Let's do this. That's where it's positive, right? So what numbers are those? What x values is it positive? What's this x value? What's that x value? 1, 2, what? 3, right? You guys see that? It's above from 1 to 3. Okay? So where's it negative? That's those 2 spots. So what's down there forever? Negative infinity, right? Up to 1. And from 3 to positive infinity, isn't it? 3 and forever. That makes sense? Or negatives below. That's where it's below. All right. It increases up to there, right? Let's change the color here. Let's go to the green. It increases from negative infinity to what x value? 2, right? And then it decreases from 2 to what? Forever, left to right, even though this arrow's pointing down, left to right, it's going up and then going down. Okay? So even though the arrows are pointing down, it doesn't mean it's decreasing all the time. Yes.
If I like switch those and I put like the 2 and the negative, or the 2 and the infinity, is that still the same thing? So like 2 less than x less than negative infinity.
Well, but x, the not, yeah, it would be wrong because you're saying the x's are less than negative infinity, which they would never be less than negative infinity, right? They're always going to be greater than negative infinity. Can't get less than negative infinity because negative infinity is forever that way. You can't get left of it. So it does make a difference. Okay? So, do we understand where the graph's positive and negative? Yes or no? Okay. Do we understand what it means by increasing and decreasing? Okay? All right, we got a little start on this section, second half of it. Thanks for your attention. Stay warm this weekend.